Hello everyone, welcome back to my computer project. And I actually remembered to charge my phone for the camera today, so going well so far. This video is going to be about this testing board again. I know it's getting a bit boring, but I actually got it working now, properly. I think all these were working last time I done a video on it, or maybe not, I don't remember. But yeah, this wasn't working, so this button here is the switch between the states you input, so like this would be your instruction, and then these bits here with the jumpers, I'll show you closer in a second. These are the default state, so whatever these lines should be by default is here. And what this button does is it switches between them, so you can go from your instruction to the default state. And yeah, so that wasn't working, there was little hiccups. Causing the data to mess up or things to read right when they shouldn't and stuff like that. So what I did was I added some capacitors underneath here. I would have added them on top, but it turns out there wasn't actually enough room to get it to go to the right place. So I did have them on top originally, and it turned out I wired them up wrong. So I tied them to the wrong thing, and then I was like, why is it still not working? Because when you flip things, I sometimes get a mirror. I don't get a mirror image. It's weird. But yeah, there's 4 capacitors there. So I think it's these two are 220 picofarads or nanofarads, and these ones are 470 nanofarads. So the smaller ones, the smaller capacities, go on the read lines. So that's this one, which is read register, or read the bus into register A and read the bus into register B. And the 470 nanofarad capacitors go on to the right lines. So what this means is when you switch state to default, so basically you want to turn everything off, the write states stay on longer than the read states, which means that anything reading will turn off and it will have that data locked in. Then the write can stop and then everything can move on. I'm not sure how good it is in terms of how quick you could switch this, because I think it might affect my clock, how I've got this set up, because I'm using diode logic here, which probably isn't the best idea. So in practice, when I build the actual sequencer, controller, all that stuff that actually executes the instructions and the machine code, I'll actually probably use transistor logic or something like that. But just not diode logic, and I'll draw a schematic in a minute showing you why that's bad. But yeah, I'll show it running. So see if I've got it all set up here. So you should be able to see the bytes down there. Everything's off. Yep. So I can read that byte. Let me scoot over here. Oh wait, what? Yeah. So you see register A, if you can see that. Register A has the 4 bits. First 4 bits lit, and register B still has all of them lit. So now I can write register A to the bus. So register A is now put in here, and then read register B, which is taking it from there and putting it into B, and you'll see that works. Now usually I can just do this. I can stop reading and then stop writing. If I start reading again, you'll see it gets random values, and if I write A, it goes back. So right, wait, let's start writing again and reading again. No, I've done that wrong. I've done it the wrong way around. Right, so I'm going to switch to the default state now. You see, nothing happens. That's exactly what's meant to happen. Nothing is meant to happen. So previously it was bugging. There is actually a couple of little light glitches. I'm not sure what's going on there, but I think this doesn't have to run at a massive clock speed. I'm not too bothered about that, about it being slow, as long as it just works, But yeah, that works now. I mean, it's hard to display that, really. It's hard to show that off, because when it's working, it does nothing. But yeah, so I'm going to turn it off, then I can change these, and nothing will affect it, because it's in the default states. Yeah, so that's that working. I'll show you this a little bit closer over on my table. And talk about the diode logic I'm using here. So here's a little close-up of it. So you can see a lot of the hacky jobs I've done to make this work. So most of all this is original. All the transistors, the resistors, diodes, all that's original. But in the process of trying to get it to work and trying to work out the bugs, this circuit changed a bit. I don't know how much, how critical any of this is at the moment, but yeah, it was all part of the process. Yeah, underneath, you see I've got these resistors here. These are tied to power, I believe. Yeah, so I think originally I wasn't actually sending any power to the switches, so they was a bit weird. I don't even remember. I might try disconnecting that and see if it still works. This is the problem. And yeah, and capacitors here, they actually go between the next to the resistors, the diodes here, and the resistors that go into the base of the transistors. So I'll show you sort of how that works. So it's sort of like an OR logic thing. So here's like two inputs, and then they go to a resistor, which then goes to the base of A. I haven't drawn schematics in ages, so I'm trying to remember the symbols. And yeah, that goes out like that. So this is the setup of these here. So there's some more diode logic here, but that's not too important for this explanation of why I added the capacitors down here. So yeah, they feed into that. So when there's no power, there's no current coming in from these, that's off. And when there is current going in there, that's on. And it's basically an inverter though, so yeah, that's the output. So to keep the gate open, I couldn't put the capacitor here because I think that would have just allowed it to discharge too quickly, to the point where they might just both turn off at the same time. So I added it here. So this is what the setup looks like at the moment, and then that's ground. So yeah, when one of these is, well, this is OR logic in diodes. So when one of them is on, that will charge up, and it will keep that charge for a while. So when both of these are off, there's still a little charge there. So in the case of reading into the registers from the bus, that's what did I say that was? I've got it actually here. Yeah, 220. So it's 220 nanofarads, and then for the writes, it's 470 nanofarads. And so yeah, the higher capacity means that once these are off, this will actually stay on longer. And yeah, so that fixed that issue between switching these states. Because when you switch these states, all these lines go low, and then these kick in to actually affect the transistor. Yeah. So I think that's all I've got for today with this project. I need to start doing more schematics, to be honest. People keep asking me to, asking if I have schematics of my project, and I literally don't. I make it up as I go. I occasionally draw a bit of a schematic, use that, and then I lose it. And I just if I need something I've already made, I'll just take the circuit out and copy it. Literally, I'll have a circuit here, and then I'll get another board and just copy it. That's that's sort of how I'm working here. So I might actually start drawing schematics. I enjoy doing it by hand rather than on computer, so I might do that. I might draw schematics for every part of the computer, and I might just do videos on drawing schematics, to be honest. That would be quite easy and fun. And yeah, I could just scan these in and upload them. So yeah, I can do schematics of that, the whole computer, general overview, all that stuff. I might do that on around the 20th, maybe next week or the week after, because like I said before, that's his 1 year anniversary. And yeah, that'll be interesting to start getting that down and actually have it solidly down. This is the computer. This is how you can build it. But yeah, I'm just droning on now. Thank you for watching, and I'll see you next time.